Today, I would like to tell you about a PR, this PR. This was my first real introduction to open source, and it was quite a challenge. There was this small gem that we needed to use, and to make it work, we had to practically rewrite all of it. The PR we ended up with was a big boy, which is never ideal, but this one had to be big because all of the parts had to change together. You've probably had to review PRs like this, and I can see you crying on the inside right now just seeing these numbers. But if you did try to review this PR, it was actually quite easy to follow because you didn't have to read all of the code changes at once. The PR was made of many commits. Each commit did one thing, and it explained what that was and why we did it that way on each of the commit messages. If you did read these commits one by one, you would build up this story that would let you follow what was happening quite easily. So even though this was a very big change, this made it reviewable. And it was actually a huge part of how we managed to get this merged. If we hadn't done this, we probably would have had to fork the gem, because there's no other way to review a change like this. Now, I don't recommend that you write PRs this size. This was a bit of an extreme case. But even with smaller PRs, it's not uncommon that you have to do several different things at once. And I do recommend that you clean up your commits so that they tell a story that is easy to follow step by step. Because the alternative is just leaving the commits as they happen, which generally looks like this. This is much, much harder to review because you can't get any useful information from the steps that were taken here. So your only choice is to read all of the files at once in alphabetical order, which is the way that GitHub shows them to you. Now, I want you to imagine that you're going to sit with a colleague and explain your changes. You will go through the files alphabetically, right? That would make no sense. Instead, you would explain this like a story with building blocks that depend on each other, starting from the basics and building a fuller picture as you go. When you submit to an open source project, you don't get to sit with the reviewer. So you have to do all of that explaining through your commits. Again, starting from the very basic changes, explaining why you did those, and then building up to the full story over the following commits as if you were sitting down with them. And this is not just our reviews, by the way. Bad commits are an even bigger problem for anyone in the future trying to understand why the code is the way it is. I found this code the other day, for example, and that was weird. Was that intentional? Is that a bug? So I Git blamed it to see if the commit message would explain how we got here, and this is what I found. This is not helpful. What you want is what Eileen showed us yesterday, right? You see this code, you see something that you don't understand, you check the commit, and there's a perfect explanation of what happened, why the code looks the way it does. And not only that, in this one, there's even a heads up. Hey, in the future, we may need to add more of these. Now, I want you to compare this kind of context with this. As developers, we all put a huge amount of time and effort into making sure that our code is maintainable. But we need to remember that the code is not the only thing that matters. It may not even be the main thing that matters. Being able to understand how we got here is a huge part of maintaining a system. So you want to do this instead and tell a story. It will make the life of your reviewers easier. It will make it more likely that your changes will get accepted. And it will leave a cleaner trail of changes for posterity. Now, of course, I didn't just magically commit all of these in their final perfect shape on the first try. This PR was months of work of changing and tweaking and experimenting. I must have gone through hundreds of crappy commits. But you can't see any of that in the final result. The final result is a pristine story without any of the smudges of the rewrites and the failed experiments. And to do that, you'll need to edit your commits. You don't want to show the complicated, windy path that you took to get to the result. You want to clean up your commits so they tell a straight story that is coherent and easy to follow. And for that, you need interactive rebase. Now, rebase is a bit of a weird tool, and it has a bad reputation. I know several folks that tried rebasing once, and they got some weird results or lost some code and never tried rebasing again. They just went straight with merging forever after that because they were scared of it. And that's fair. As usual with Git, the UX is pretty obscure. The error messages are cryptic and scary. It feels like if you make a small mistake, you can lose your commits and hours of work. Rebase is genuinely hard to get into at first. And the problem is that unless you have a good chunk of background information when you start, it's really hard to understand what it's doing and how. And so when something goes wrong, it feels arbitrary and kind of mean, to be honest. So let's fix that. Today, we're going to learn how you can do this too. We'll learn how Rebase works and how you can make your commits cleaner, get your changes accepted, and earn the admiration of your peers and the gratitude of anyone who Git blames your code in the future. First of all, though, hi, my name is Daniel, and I work at Indeed Flex. We are a flexible staffing platform based in London. As you probably noticed, I'm not originally from London. I come from Argentina, so in case you're wondering, that's the accent. And with that out of the way, let's get rebasing. Now, as I just mentioned, when you want to understand Rebase, it's useful to start with a little bit of background. We want to know a little bit about how Git works under the hood, because if you know how Git works, it makes things much easier to understand. Now, I'm going to keep this short. There are only 3 important things that I want you to remember. And by the way, I'm going to make some simplifications here. Don't add me. I know some of this is not exact, but it's a useful way of thinking about how this works. Now, as you know, as you evolve your code, you end up with a series of commits for all of your changes. Each of these commits lets you see the state of your code at that point in time. But the commits don't store the whole state of your code at that time. Instead, each commit depends on the one that came before it, which we call the parent, and it represents only the changes that we made to files on that parent. This is the diffs that you're used to seeing. It only represents these differences, these changes. So this commit here doesn't really have your code at that point in time. The code you get, if you check this commit out, is the result of applying this diff to the code in the parent. But the interesting thing is that because each commit only represents these changes, they can exist independently of their parent. You can move them around. So in this example, for example, you have a separate branch. The code in that blue branch is going to be different from the one in the yellow one, but I can totally take that top commit and just copy it over here, and whatever its diff was gets applied to the code in this new parent. And in fact, if you've ever done a cherry pick, that's exactly what it does. So important thing to remember, number 1, commits are just a diff, and you can apply them to a different parent if you want. You can move them around. Now, if we go back to our commits, as you probably know, Git lets you use git checkout to jump to any commit and see what the code was at that point. But to do that, you need to refer to these commits somehow. And each commit has a unique SHA that you can use as a handle to refer to it. So if you want to check out these commits, you can just git check out their SHA. But that is really inconvenient. You don't want to be typing SHAs all the time. So instead, Git gives us references. Basically, we can label these commits to make it easier to refer to them. And there are 2 types of references, tags and heads. And these are both almost exactly the same thing. It's just a convenient name that you can attach to a SHA. And in fact, if you ever look into the .git directory where Git keeps all its info, that's all they are, a tiny text file with the SHA of the commit that they point to. Now, you shouldn't normally do this, but if you create a new text file here and put the SHA of a commit inside, you've just created a branch. That's all they are. Now, I said there are 2 types of references, tags and heads. And the difference is that tags just point to a commit and don't do anything else. Now, they're useful as historical markers for something that happened at some point in time. We normally use them to keep track of which commit we released in a given version. Now, heads are almost the same, but they have a special trick. Let's say we're going to make a new commit here. You normally have some branch or head checked out, and that head is pointing to a commit. That's the one we will be diffing against in the new commit we add. So the new commit will have this as its parent, and when you make that new commit, it will not only show up here at the top, but the head will also automatically move to point to it. Now, that may sound a bit weird or confusing, but this is the usual Git behavior that you're used to every day. You're normally on the main branch or on some other branch, and that's your head. And every time you commit, the branch moves forward to point to the new commit you just made. And that, in a nutshell, is all that a branch is. It's just a reference to a commit that moves forward when you add new commits. That's it. And the reason I'm telling you this is that understanding how these heads or branches move is the key to understanding Rebase. So important thing to remember, number 2, branches are just a pointer to a commit, and that pointer can move. By default, they just move forward, but you can repoint them wherever you want, whenever you want, by doing a git reset hard. For example, you can reset this head here, and now this is where your main branch is. Now, you'll notice that those 2 commits at the top have now effectively disappeared. They are orphaned now because there's no head pointing to them. Keep that in mind. We'll come back to those later. Let's talk about merge for a second. Here we have a very neat linear set of commits. Every commit has 1 parent and 1 child, but there's also a number of special cases. First of all, a commit can have more than 1 child. 2 commits can have the same parent, and this is how we get separate branches, right? You can have your main branch here in yellow, but you can also have another commit that depends on this guy down here, and then a bunch of other commits that depend on that one. And this is basically what happens when you make a feature branch, and then generally you want to make a PR to merge it back to main. So one special case is 2 children. The other special case is all commits have a parent, but some commits can have 2 parents, which is what happens when you merge a branch into another. Let's undo a merge and look at that into a bit more detail. When you merge this branch into this one, Git will go back and figure out where the branches diverged. Then it will take all of the changes from all of the commits in the branch since then, and it will collapse them into one big diff and apply that diff to the branch you're merging into. And that is your merge commit. If you look at its diff, it's the cumulative changes of all of the commits in the branch. And then the target branch moves to point to that. So that's how merge works. It collapses all the individual diffs into a single one and puts it in a single commit with 2 parents. Now let's talk about rebasing, finally. If instead of merging, you rebase onto another branch, Git will do something similar. It will also go back and figure out where the branches diverged. It will also take all of the commits in your branch, but it won't collapse them into one. Remember we said earlier you can take a commit and reapply it anywhere? When you rebase, instead of collapsing your commits, Git will apply them one by one to the head of the branch you're rebasing against. So you still have the same commit history, but you also have all the latest code from the target branch, in this case, main. And then it will repoint the branch reference to that new head commit. That's basically all that rebase does. So important thing to remember, number 3, when rebasing, Git will apply all of the commits one at a time and then reset the branch head. Now, just like the last reset we did, you can see that we have these orphaned commits. You don't normally see these because Git's command line and graphical clients generally only show you commits that have some sort of reference pointing to them. And nothing is pointing to these. But they're still there. They didn't go away. You can still Git check out any of them, and you can also Git reset your branch back to them if you want. And that will effectively, in this case, undo the rebase. And now these are the orphans. Now this is going to be key to recover from problems, so we're going to talk more about that later. But that's the main thing to remember here. We can easily repoint branch heads anywhere, anytime, and with rebasing, you will do that a lot. It's a pretty fundamental tool. All right, enough about internals. Let's talk about what we've all been waiting for. Let's talk about rebase-interactive, how you can edit your commits and make your history gloriously clean. Rebase-interactive is the exact same thing as rebase. It will take all of your commits, and it will apply them one by one, but you get to interfere in the process. You get to change how these commits get applied. And this lets you do lots of fun things. You can change the order of the commits to present the story more clearly. You can add new commits in the middle of that story. Or if you have a commit that's doing too much, you can split it in 2. Or you can take 2 related commits and actually squash them into 1. And combining all of these operations is how you're going to create the prettiest commits anyone has ever seen. Now let's see how this works. Here we have a bunch of commits in a branch, and we want to rebase them against main and modify them. Now these commits are completely made up, but I try to make them somewhat similar to what happens when we're developing. And while the particular commits don't matter much, I want to tell you a bit about them because it will make the next parts easier to follow. In this branch, we're adding a feature. After running CI, we needed to fix a couple of problems. We also tried a thing that didn't work, but we kept it in a commit in case it was useful later. It wasn't useful, so we actually want to get rid of this. This was another fix, and when we committed this, we were in a rush, and we didn't have time to write something decent. We need to fix this commit message to add a better explanation. We also found some other problems that got in the way in other parts of the code, and this shouldn't really be on this branch. And in a proper open source submission, you should make a separate PR. But in your own code base, you would generally just leave it there. At least we left it in a separate commit. And then, of course, Robocop complained about stuff, so we fixed it to appease our robot overlord. So here's what we want to do with these changes to clean them up. First, we want to drop that experimental commit. Then we want to fix this commit message. We want to move the unrelated changes, so they are first. And we want to combine these 2 into 1. So let's see a really quick example of how we rebase interactive and how it can help us clean this up. We start on a branch, and we do git rebase main --interactive. This will open up your favorite text editor with a list of all of the commits in your branch. And you can see here a bunch of commands on the left. As you can see, this whole thing is just a bunch of text. And the idea here is that we're going to tell Git what to do with each of these commits. By default, it will pick every commit. And pick just means apply this commit, like we saw earlier. But we can also do other things. Remember this experiment commit we don't need? We tell Git to drop it. The next commit has a crappy commit message, so we're going to reward it. This one is unrelated, and we want it at the top. So we're going to cut this line and paste it up here to change the order in which the commits will get applied. And finally, these two need to be merged into one, so we will squash them. Then we exit our editor, saving the file, and Git would do what we just said. It will apply the commits we told it to in the order that we said. This is the one we said it should squash. It's going to let us edit the message. And then it's going to skip over the one we dropped, and when we reach the one we wanted to reword, it'll open the editor again, just like when we git commit, so we can edit the commit message. And now we're done. Successfully rebased. Now that was a lot, and I want to go over what happened in a second. But first, I need to point out something about rebase that I think at the beginning is super confusing. When you're looking at git commits, either in the command line or in a graphical client, you always see old commits at the bottom and newer commits at the top. But when you're Rebase Interactive, they show the other way around. The first commit you made will be at the top, and the latest one at the bottom. And this is the same way GitHub shows them to you, and it makes sense when you're editing your commits, but it does make it harder to follow what's going on when you're switching from editing the commands to looking at the results. So keep that in mind. So let's look at what just happened in the rebase. These were the commits before. This is what we told Git to do. Remember, it's upside down. And this is the result. Now you can see we got rebased on top of main, but also now the commits are in the shape that we said. This is how that happened in order. We reordered this one to be first. We squashed these two. We dropped that experiment. We reworded this fix, and then we just picked that last one. Now this is an amazing tool, and once you get used to thinking about commits in this way, you can take full control of every line of code in every commit. It's incredible power. But again, a lot just happened really quickly, and that was maybe a bit abstract. So let's look at these commands in detail and talk about when you should use them. First, there's reordering. Now, reordering is one of the simplest tools we have, but it's super powerful to control the narrative of your PR. The order in which you add your changes can make it much easier or harder to understand what's going on. For example, it's common to have a few things that are routine cleanups that maybe are a bit unrelated to the PR, but you need them there. I like to put those commits at the very beginning, so you get them out of the way before we start on the real changes, and then they don't break the flow later. Or if you have a thing that you first refactor so you can make it easy to change later, and then you make the easy change, you want that in two separate commits, but you also want them together, so it's easy to follow the story. And mostly, reordering is important for other techniques we will learn. For example, if you want to squash two commits into one, but there's other stuff in the middle, you first need to reorder them together, and then you can squash them. Now, doing it really easy is not even a rebase command. You just change the order in which commits get picked by editing the file and cutting and pasting lines around. The next command is two, actually, squash and fix up. These are two commands for doing the same thing, which is combining several commits into one. Now, the reason there are two commands is the commit message. If you squash, it will add the message of the second commit onto the first one. And you'll be used to seeing this if you use the squash and merge button in GitHub. Fix up, instead, will discard the second message, and it's always the better option. I have to say, I've been manicuring commit histories for years now. I have never once used squash, because the resulting commit message generally ends up being garbage. If you're taking two commits and combining them into one, you generally don't care about that second one, so you don't want that message. And even if you do want parts of it, I do think it's better to fix up always, and then at the end, look at your actual commit message, look at the changes, and then reword it to describe exactly what's happening. It's going to make it much more coherent. Now, when you have several commits that you want to turn into one, what you'll do when rebasing is you will reorder them so they're next to each other, leave the first one as pick, and you're going to set the other one as either squash or fix up. When you finish the rebase, this will leave you with only one commit with the code of all of them. Now, because we chose squash, Git will open the text editor, and you can see here the second commit message is still there, and the third one isn't. It's commented out. If we had just chosen fix up for both, you don't even get the editor, which saves you even more time. Squashing is one of the most useful techniques, because there are many situations where we start with separate commits that really should be only one. For example, you wrote some code, then you remember the tests that you were supposed to write, so you put them in a separate commit. Having the tests separate doesn't really help tell the story. So that's a squashing. Or you wrote some code and later changed it in a way that doesn't really deserve calling out explicitly. That's a squashing. You took you several tries to get the test passing. That's a squashing. You want to be ruthless here. Every commit that you leave in the end needs to stand up on its own and have something interesting to say. If you can't come up with a commit message that's particularly insightful, that's a squashing. All right, let's look at reward now. This is probably the easiest to understand, but again, it's a super powerful one, because a good commit message is probably the best thing you can do for your reviewers and for anyone in the future that's looking at your code. It's trivial to do too, we already saw it. You mark a commit as a reward, Git will open the text editor and you edit the commit message. So before you submit your PR, actually read your commit messages, compare them with the code, and if any messages are not perfect descriptions, just reword them. Another easy one is drop. We also saw it before. Drop just gets rid of a commit. Sometimes we commit things that don't really belong. They may be temporary, experimental, or maybe you move the code to another branch and a separate PR. Whatever the case, if you don't need it, just drop it. And now we get to the big guns. Edit is the most misunderstood and the most powerful command in Rebase. The naming, however, is terrible, which makes it really confusing, because it sounds like you'll be able to edit the commit directly, and you can, but it doesn't work like you might expect. What I like to think of edit as pick and pause. When you mark a commit as edit, Git will apply it, and then it will stop and return you to the command line, and now you can do whatever you want with those commits that have been applied, and when you git rebase continue, Git is going to go like, sure, whatever, and then just take it on faith and just leave them as it is, continue applying the next commits. For example, we have these 4 commits there, and we choose to edit the second one. Git will apply the first 2 and put us in the command line. Now you can see here that the first 2 commits there are already applied, and we can now do whatever we want. For example, let's create a new file, add it to Git, and then make a new commit. And then when we rebase continue, it's going to continue applying the rest of the commits that we had pending. And you will see now in a second that instead of the 4 commits we started with, you now have 5. We just added a new commit right in the middle. So hopefully this gives you an idea of what's happening. We pick the commit, pause, and you can do whatever you want. And the possibilities here are endless. Of course, the easiest thing to do is to actually just edit the commit you chose. When Git drops you in the command line, you can modify some files and git commit amend, which is what the rebase message tells you to do, and then git rebase continue to apply the rest of the commits. Now, if you actually have a manual amend to do to a commit, this is an option, but I find that this is actually pretty rare. What we very often do is undo the last commit and then reshape it. After you say you want to edit a commit, you can git reset head up, which is going to get rid of the commit, but leave the changes in your Git status. And now you can do anything you want. For example, let's split that first commit in 2. After we edit it, we can git reset head up, which is going to undo the commit, but keep the changes. You can see here in the Git status that we had 2 files in it. Let's say those were 2 separate changes, so we're going to commit the 2 files separately into 2 individual commits. So that's the first commit, and that's the second one. Now you can see now that we have 2 commits applied instead of the one that we already had. And then when we rebase continue, you will see at the bottom how we have split the first commit in 2. And now we have all of the pieces to fully understand the magic, because the combination of splitting commits, reordering them, and then squashing is what will give you ultimate power over your commit history. For one of the most powerful moves, the combination of these 3 actions means you can move code from one commit to another in 2 rebase steps. Let's say you have these 2 commits, A and B, and you can see the bottom one does 2 things. And we would like that top bit of code on the second one to be in commit B. No problem. First, we edit commit A and split it into 2 and finish the rebase. And then in another new rebase, we take that new A2 commit, we move it after commit B, and then we mark it as fix up. So the 2 become 1, and boom, we've just moved the code. Now this is extremely powerful, and mastering it is going to make the most difference to your PRs. And that's it. That's Rebase Interactive. You get to reapply your commits one by one, but interfere with how that happens to remold them to whatever shape you need. And these are the commands you have to do that. Now, this is a really simple but subtle tool. It will let you do pretty much anything you need to do, but you need to get used to it and sometimes get a little creative. But with some practice, you will be making pristine commits in no time. Now, if you ever tried rebasing, you know that sometimes it can go wrong. So let's talk about how to recover from that, because it will go wrong, quite often actually, but that's okay, because we have 3 easy ways to recover, and that's part of the normal process of rebasing. First of all, we have git rebase -- abort. If you're in the middle of a rebase and you want to back out, you just git rebase abort, and Git will reset you to where you were before you started your rebase. Doesn't matter how much you've modified so far. If the rebase didn't complete, you can abort and go back to before you started. And I use this all of the time, mostly when I get surprised. When you're rebasing, there are some things that you expect to succeed, and there are some things that you expect will give you a conflict. So you sort of know because you know your code. Lots of times, there are operations that seem harmless and should complete successfully, but all of a sudden, they will give you a conflict. Generally, when that happens, it's because my mental model of the commits and decoding them is wrong, so I generally abort and look at them a bit clearly and just take a different approach. I also do a lot of experimental rebasing, mostly like, I wonder if I could just do this and it will work or if it will conflict. If it does work, awesome. If there are conflicts, I may back out and then try another way. Now, if your rebase did finish successfully, but for some reason you want to take it back, abort is not going to help. It's too late for that. A super simple technique to recover is to take advantage of GitHub. Before rebasing, push your branch. Then try your rebase. If you're happy, great, push again. If you're not, you should simply reset hard to the origin branch and you're back in business. Everything that you did after pushing to GitHub is gone, and you can now try again. Another advantage of this technique is that after you rebase, sometimes maybe you're not sure whether it went well or not, or you may have changed some code that you didn't mean to. If you do this, you can diff your branch against origin and make sure that despite the changes to the commit structure, the code is still the same. Now, sometimes you didn't push to GitHub, or you did, but then you thought the rebase had gone well and pushed again, and later you find out there was some disaster or something else has gone horribly wrong. Then it's time for the ultimate time machine, Git reflog. Now, you're not going to use this very often, but when you do, boy, you're going to be happy it's there. Reflog is one of those tools that are incredibly simple and incredibly powerful, but at first, it makes absolutely no sense. When you run it, it looks like this. Every time I run it, I swear I feel like I'm having a stroke. But it's actually really simple. We just need to remember two things to understand what's happening. First of all, as you jump around the repo, you're always standing on some commit. And wherever you are, that's your head. You are a commit, the head moves with you. You check out a branch, the head comes along. You rebase a branch, the head follows you around. And every time that head moves, Git keeps a log of that. That's the ref log. It's a log of all of the SHAs that the head has been in, and also what command took it there. The other thing to remember is what I mentioned earlier. When you rebase, the old commits don't go away. They're now orphans, and you can't see them, but they're still there, waiting, hoping that someday you will love them again. And reflog is how you can do that. Let's look at how. This is a reflog output from the sequence that I just showed you. We check out main, or where main used to be. We add a commit. We check out a branch. And then we rebase the branch. And you can see here, rebase does what I described earlier. It first checks out main, then picks the commits one by one, and then moves the branch to the new place. Now, those SHAs in the terminal are the key to undoing your rebase, or undoing anything, really. You just need to find where the rebase started, which can be a bit tricky sometimes because there can be a lot of noise here. But if you start from the top, you are basically reading your rebase in reverse. And then you have where the head was just before starting the rebase, which is here. So you just reset hard to that SHA, and your branch is now back to where it was. Now, of course, after resetting hard, just like after any rebase, you will need to then push force to GitHub. And that's how reflog works and how it can help you recover from all sorts of disasters. Now, as a final wrap-up, I want to repeat this. If you're going to remember one thing from this talk, it's this. Whenever you're rebasing, remember that Git is applying all of the commits one by one. So if, for example, you stop because of a conflict, then you need to see how far you got, what the current commit is doing that it couldn't apply, and think how we apply that commit's diff to the code in this current state in the middle of the rebase. Just remember that and you'll be fine. By the way, I've talked about the very basics, particularly the internals, and I had to make a lot of simplifications and gloss over a lot of stuff. But being really good at Git is one of the most important skills that you can have as a developer. So if you want to learn a bit more about how Git works internally, the book Pro Git has an excellent chapter on all of the internals, and it's free to read online on that URL. It's extremely eye-opening how simple Git really is inside, and this will give you the mental model to always understand what's happening. If you read this book, you will get better at Git, promise. And that's all, folks. I hope that explanation makes sense. Hopefully you want to go home, try these, and become amazing at Rebase. Your colleagues and all open source maintainers will thank you for it. Now, before I leave you, I do have to mention that indeed Flex, we're growing super fast, and we're hiring all over Europe, so check this link if you're Europe-based. And I have some stickers here if you like. And with that, I'll see you in the hallway track. Thank you.